Good afternoon, everyone. So we are starting our today lecture of Geotechnical Engineering 2. We are in the week 6 of this coursework. This is the 12-week long session in which we are studying Geotechnical Engineering 2. Over here, I am solving the question for you. Whatever required, whatever doubt, I try to revise those concepts as well as take some additional questions which will help you in your assignment or ultimately at the final exam through which you get the certification for the course. So this is the course which is taught by Professor D.N. Singh sir. My name is Sumit Kumar. I am PhD research scholar at IIT ISM Dhanbad. This is the second time I am taking this course. So whatever the doubt you have, you can ask me over here or on the forum as well. I will try to answer those. And any confusion or any questions which you may uh, have any problem you want to ask, you can text me over here as well as if you can give me an email as well, as I will write my email ID in the comment box in the chat box and I will pin that so I can solve that out maybe in the today class or the subsequent class, whichever be feasible. Okay, so I try to add some instructions before going ahead, and the basic instruction is like that this lecture is going to be take place for 2 hours, and this is the 12-week long, 12-week sessions in which we are studying the geotechnical engineering too. So I suggest you to attend all the lecture. First of all, go through the lecture of the sir, and if any doubt over there, you can ask me over in these sessions, and I will try to sort out whatever the problems you are going through. And this session is going to be take 2 hour long, and I will take this session in one go. So try to be there in the meeting. If due to any problem or due to network connection, if my connection goes out, I will rejoin and the lecture start from there only. So if such situation arises at any point of time, please we remain in the meeting. I will rejoin and start from there only. Apart from that, what are the content I am discussing over here will be shared with you through the Google Drive link. The link of the drive link is already shared with you by the NPTEL team. And the this lecture I am presenting right now is also recorded, which will be shared with you through the YouTube link, and that will also be shared with you by the NPTEL team. So that's not the problem. So with this, now I can start the today's session. So first of all, I try to take the quick recap of the last session, then move ahead with the new concepts. As you remember, in the last question, we have solved 15 to 16 problems along with some other concepts. So I will just give a quick recap at what we have gone through, then we start our today's session. So we have studied about the interpretation of triaxial test result in the geotechnical engineering, in which we have found that the how triaxial test setup works, what is the back pressure, how the pore water pressure and the different condition is achieved. The result often from the triaxial test can provide the valuable insight into the characteristics of the soil and the suitability of various construction practices we come to understand through our study, right? We also come to know about the purpose of the triaxial test, that the triaxial test is primarily conducted to identify any issue with the soil as well as to validate the effectiveness, compactness effort. We also come to know that by measuring the pore water pressure during the triaxial test and in the undrained testing, the engineers can gain a better understanding of the soil response and behavior under the different stress condition. We also come to know the pore water pressure, like the pore water pressure measured during the triaxial test can help in determining the nature of the soil and its response. By analyzing the pore water pressure, the investigators, engineers can classify the soil either as normally consolidated or the over consolidated. We come to understand about the over consolidation ratio, that the stress applied in the past to the stress applied in the present is the ratio which depends the over consolidation ratio. We also understood that about the Mohr Coulomb failure envelope and how it formed. We understood that the intercept on the toe axis is said to be the cohesion, and the angle with the horizontal axis is said to be angle of internal friction when we draw the motor envelope, the result which outcome from the test. We also considered about the economic considerations, and so we justify that the professional engineer must careful to analyze the test carefully to optimize the economic needs of the site. We also come to understand the connecting material property, like we understand the significance of pore water pressure, and the transition to the another class of problems centered to the compacted field material. We also come to understand about the compaction and the soil characteristics here, and strength interpretation, in which we understand the relationship between the deformation and stress on the dry and the wet side of optimum, as well as we understood a holistic approach involving the particle size distribution, compaction curve, compressibility, and the triaxial tests. So these things we have gone through, and at last in the last session we come to go through the some of the problem, specifically where we understood the different concepts, that how the problem interrelated to the triaxial test is going to be solved out. So these are the problem we have gone through during the our last session. So I think so up to this, I will remain over here, and now I will carry forward with the new concepts, so that will lead to you better understanding of the things which we are discussing right away. Okay, so now I will share the new content with you. Okay, I think so my screen is visible, right? Yes, yes. Okay, so no problem, we will go ahead from here. Okay, so now we are starting with our new content. So first of all, okay, okay. See, so we are discussing over here. First of all, starting with a question, we say that a conventional drained triaxial compression test conducted on normally consolidated clay sample under the effective confining pressure of 200 kilopascal, deviating stress at failure was found to be 400 kPa, and an identical specimen of same clay sample is isotropically consolidated to a confining pressure of 200 kilopascal and subjected to the standard untrained triaxial compression test. If the deviating stress at failure is 150 kPa, the pore pressure developed in kilopascal. The question is that, so how we are going to solve? Okay, so first of all, we write the things which we have known. Okay, so I will take the pen for this purpose. Okay, see, the question is like the conventional drained triaxial test we are performing over here, right? Allow me, give me a time, minute, please. Okay, I will take a pen. Right. See, the question is saying that a triaxial test is conducted on normally consolidated. First of all, the normally consolidated is important word. Drain triaxial is important word, because on the basis of that, the pore water concentration we will take care of. Confining pressure of 200 kilopascal. This means the value of sigma 3 is 200. kPa. I will not write the unit over here. I will write the number only. Okay, 200 kPa. Okay, I will write it. That's not the problem. Right. So, the sigma 3 is given and the diabatic stress at the failure was found to be 400 kPa. So, sigma 1 minus sigma 3 is sigma 1 minus sigma 3 is 400. That is sigma d. Right? Okay. Okay. So over here written that the deviatic stress at failure is found to be 400 kilopascal. An identical specimen of the sample clay is isotropically consolidated to the confining pressure. An identical specimen of same clay sample isotropically consolidated to a confining pressure of 200 kPa again and subjected to standard undrained triaxial test. Over here, undrained, standard undrained is an important word. Triaxial test. If the deviating stress at failure is 150 kPa, then the poor water pressure develops. It is asking. So first of all, we know our famous relation, that is sigma 1 equal to sigma 3. Sigma 1 equal to sigma 3 10 square 45 plus 5 by 2. I think so. You have remembered this relation because I have written several times during the study teaching as well as during the solving the question in the last session. So you are much aware about this term. Sigma 1 equal to sigma 3 times square 45 plus 5 by 2 plus 2c times 45 plus 5 by 2. Right? Right? So, okay. So we are using this equation only. So first of all, we know sigma 3. We also know sigma 1. That is sigma 1 is nothing but 600 over here. This implies sigma 1 is equal to 600. Okay, and this test is drained triaxial test. So over here you consider the value of drain triaxial test. So you consider the value of c as 0 and find the value of phi, and after that, as you know, in this case the confining pressure of 200 kPa is subjected to a standard undrained, so the 150. So you consider sigma 1 minus u equal to sigma 3 minus u times for 45 plus 5 by 2. You will get the answer. So I will show you the solution directly. So over here, first of all, what I say, see, first of all, he considers sigma 1 equal to sigma 3 times square 45 plus 5 by 2 plus 2c tan 45 by 2. From here, we are able to find the value of phi as 30 degree, right? Pi equal to 30 degree, what I have said earlier. After that, we consider sigma 1 bar equal to sigma 3 bar times square 45 plus 5 by 2. Sigma 1 bar is nothing but as sigma 3 bar is 200. Sigma 3 bar is 200. So sigma 1 bar is 350. So because sigma 1 minus sigma 3 equal to 150. So sigma 1 bar is equal to 150 plus 200, that is 350. So sigma 1 bar is 350 equal to sigma 3 bar is nothing but 200 tan square 45 plus 5 by 2. Pi is already known, tan square 45 plus 5 by 2. 45 plus 30 by 2. Right. So from here you are able to find the value of u, because the 350 minus u and 200 minus u equal to 10 square 45 by plus 5 by 2. So we are able to find the value of u, that is the pore water pressure, as 125 kilopascal. Okay, so I will revise it again for you. See, first of all, question is asking that a conventional drain triaxial compression test was conducted on a normally consolidated sample or under the effective confining pressure of 200 kilopascal. So over here, first of all, we have written the value of sigma 3 as 200. Then the deviating stress at failure was found to be 400. So 400 is the negative stress at failure. After that, we apply our interrelation, that is sigma 1 equal to sigma 3 times cos 45 plus 5 by 2 plus 2 c tan 45 plus 5 by 2. From that relation, we are able to find the value of phi, as it is a direct triaxial test. So we assume the value of c as 0, and we are able to find the value of phi as 30 degrees. So you can see over here as well. First of all, we apply our relation, famous relation, which we used to recite many times, and by applying this relation and considering the value of c as 0, we are able to find the value of phi as 30 degree. Afterwards, we move ahead and we apply the our again the same relation for the effective condition, because for the second case 200 for the undrained test is given, and so the 200 minus u, 200 plus 150 equal to 350 is the sigma 1, and sigma 3 bar is 200, which is used over here, and the value of u is calculated by putting all the value, because only u is unknown over here. So you are able to find the value of u as 125, right? Okay, so I think so up to this, there will be no problem in anyone mind. Okay, but now I will move to the next question. Okay, give me a minute. Okay, control shift. See, the question again is the second question over there. The total horizontal and vertical stress at a point in a saturated sandy medium are 170 kPa and 300 kPa. Total horizontal and vertical it has given. Okay, so I will take a pen again. So you understand that 170 and 300 are the total horizontal and vertical. So the vertical in the deviative direction, horizontal in the confining direction. The static pore water pressure is 30 kPa. Static pore water pressure means the water pressure. Static pore water pressure means the pore water pressure developed over that site during the static condition as well. At failure, the excess pore water pressure is 94.5 um, kilopascal, which you can see over here, and the shear stress on the vertical and horizontal plane passing through the point x is 0, so the effective cohesion is 0, and the effective angle of internal friction is even 36 degree. So shear strength he is asking, so we know S equal to C plus sigma n tan phi, but we don't know the value of sigma n, so we are going to calculate. So sigma x and sigma y is known, and we know the interrelation as sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 sine 2 theta, and sigma x minus sigma y by 2, whatever be the relation I will show you. Over here you can see we know the relation for sigma n as sigma x plus sigma y by 2. Okay, so I will write, because over here the thing are not written. So we know value of sigma n as equal to sigma y plus sigma x by 2 plus sigma y or sigma, or whatever the term you want to say, sigma y minus sigma x by 2 sine 2 theta. Okay. See, so this is the relation which is used over here to calculate sigma n as 300 plus 172 by 2. 300 is in the vertical direction and 170 in the horizontal direction. So sigma y plus sigma x by 2, sigma y minus sigma x by 2 cos 2 theta. Sorry, there is a error over here. So I have to take the eraser, and I have to do this to cos 2 theta, right? Right. So you can see over here, so we are able to find the value of cos 2 theta. So we are going to apply the same equation as sigma y plus sigma x by 2 plus sigma y minus sigma x by 2 into cos 2 theta. So theta is the alpha over here. So alpha is equal to nothing but 45 plus 5 by 2. So we apply 45 plus 36 by 2, that we are able to find as 63 degree. We are able to find a 63 degree, and after that by applying the relation we are able to get the value of sigma n as 196.79 kPa, and sigma n dash equal to sigma n minus u, that is 196.79 minus 30 feet, and again 94.5, which is developed pore water pressure measured 94.5 at the failure, which is written over here at failure. Additional this pore water pressure, excess pore water pressure is developed. So we will subtract 196.79 minus 30 minus 94.5, and we are able to find the value of sigma n dash h 72. As we know, s tau equal to c plus sigma n dash phi, and the value of sigma and dash is already known, and tan phi equal to 36 degree is also known to us. Phi equal to 36 degree is over written over here, internal friction 36 degree. So we are able to find the value of shear strength at 52.52 kPa, which is going to be our answer, right? Okay. Now see, now we will move ahead and we talk about the stress path in geotechnical engineering. We are not talked about the stress path concept earlier, so we are taking this forward during this session for the better understanding of the subject. See, up to this class we are focused on this concept. In the next class we are going to see the earth pressure theory, like the active earth pressure, passive earth pressure. So some new thing are going to come for our discussion. So you will see that that's not the issue. Okay, right? So see what I am talking about. So I am talking about the stress path in the geotechnical engineering. So starting with introduction, first of all, this is a journey through with the stress path in geotechnical engineering. We are going to understand. We will explore the concept of total stress path, effective stress path. The total stress path minus the static pore water pressure resulting the effective stress path, and this is discussed in very brief earlier as well over in the geotechnical engineering one course, when you are going to your chapter 2, in which you are studying about the total stress, effective stress, pore water pressure. Over there the slide idea you got develop about these concepts as well. So we are talking about that in detail over here. So the stress path play a very important role in analyzing the soil behavior, and for the designers and consultants, this is one of the most enlightening knowledge. When we see in triaxial testing, we have seen its significance in the geotechnical engineering at various aspects, from the construction of any infrastructure project to the bridge to the railway to the foundation to the slopes. Everywhere the triaxial test to find the shear strength is very much important. When we talk about the stress path, it is a powerful tool for interpreting the test result and understanding the soil behavior. When we are going ahead, we talk about the different type of stress path. So the type of stress path is mainly the total stress path, effective stress path, and the effective stress path is nothing but total stress minus pore water pressure, that is nothing but the static pore water pressure, because we are not considering any other condition when we are talking about the effective stress path. When we talk about the geometrical transformation, so the transformation of shear test result from tau sigma plane to PQ plane for the simplified analysis is the stress path. See, when we talk about the stress path, I will draw one of the thing for you. Okay, I can't. Over here, you see. When we plot the PQ curve, we draw the PQ curve. This is nothing but uh, sorry. This is Q and this is P, and P is sigma 1. You know sigma 1 and sigma 3 exactly. So P is sigma 1 plus sigma 3 by 2, right? And Q is sigma 1 minus sigma 3 by 2. Okay? You see that? Okay, we are talking about the relationship between the tan, beta, and k for the Earth pressure coefficient and phi as the angle of internal friction. So, employing in the geotechnical transformation. Okay, so I will write about those as well. So, see, we know Ka, the coefficient of active Earth pressure, Ka is nothing but 1 minus sine phi, or I will say sine phi only, 1 minus sine phi by 1 plus sine phi, right? And the value of passive earth pressure coefficient is the converse of this. When we say Kp, the value of Kp, that is nothing but 1 by Ka, 1 divided by Ka. Okay, and for the earth pressure in rest condition, this is the active condition, the another is the passive condition, but there must be situation when the earth is in rest condition. So over here k is written as 1 minus sine phi, or mu by 1 minus mu, 1 minus sine phi, 1 minus sine phi, or mu by 1 minus mu. Mu is the Poisson ratio over there as well, mu by 1 minus mu. Okay, right. See, okay, so we are talking about the total stress part. So first of all, start with its characteristics. So defining the characteristics of total stress path is always inclined at the 45-degree impact conditions. How the total stress path changes under the different holistic condition, back pressure and the standing water table. So sometimes you can see the hydrostatic condition or the surcharge may also be applied. So when we talk about the hydrostatic condition, so hydrostatic condition is resembled over here, in which either over here as well as over here, in which either the tensile stress is applied from the all direction, or the compressive stress is applied in the all direction. So if we consider any block in a water body, for understanding this, consider this box, and there is a water filled over here, water. Okay, so on this block, the stress applied from all directions is equal. So this is in the hydrostatic condition. This block is under hydrostatic condition, right? Okay, so this block is in the under hydrostatic condition because the compressive force applied on this block from the all direction, from right, left, from the top, bottom, from the corner, is equal. But when we consider the stress, we consider only the horizontal and vertical direction. So stress in all the direction over here is uniformly distributed on this block. When we consider this is a 3D block which are in the water, so that aspect is fulfilled over here. That's what it is represented over here, right? Okay, see, now we are talking about the effective stress path. We have talked about total stress path. We now are talking about the effective stress path. When we talk about the effective stress path, we are going to form the nonlinear behavior of ESP under the undrained shearing condition and the connection with the shear failure. So, understanding the path lead to the shear failure. Understanding in a better manner, as you are going to plot over here sigma 1 plus sigma 3 by 2, sigma 1 plus, we will also solve one problem on this concept, sigma 1 plus sigma 3 by 2, and over here sigma 1 minus sigma 3 by 2, as you are aware about the concept. So sigma 1 minus sigma 3 by 2, and the stress path get formed in the linear direction. This is a horizontal line. Okay, so let me take the eraser and draw it again. Pointer option. Okay, so now see, I will take a pen again, and we draw a linear line, and the point mentioned over here is representing at in the different conditions sigma 1 and sigma 3. You have remembered now that we are earlier drawing the stress like sigma 3 and sigma 1 and sigma 3, we are earlier drawing as this is the sigma 3, this is the sigma 1, right? And then sigma 3 gets changed and sigma 1 gets changed, and then we draw a common tangent crossing through this, like, okay, I think so you have remembered this. And by this we are going to form the Mohr failure envelope. In this condition, these stresses get transformed in this fashion for sigma 1 minus sigma 3 by 2 on the y-axis and sigma 1 plus sigma 3 by 2 on the horizontal axis, and we are able to find our stress path. So, what is the difference over here? When we study the critical state soil mechanics, over there, these concepts are quite promising, and we get a better development understanding regarding the same. So, we will see that we are not keen to do so because that is the part of the advanced soil mechanics in one way or the other. So I will not touch that part. And when we say total stress path minus the pore water pressure, this is nothing but the effective stress path. And when we talk about its significance, it is important in the scenario involving the static pore water pressure is there. And in the several aspects we see the static pore water pressure is there whenever at any places if the water table retain over there. So at that situation the static pore water pressure is always present, so we want to eradicate that, so that is the effective stress path, fulfill that things in one way or the other, right? Now we talk about the practical application. So this will be helpful in the design implementation, that how stress path impact the design decision and the analysis. Geotechnical consulting, the real world scenario where the stress path assists the consultants in making the informed choices. Because if the variation of stress path is known to us, the designer, the consultants are more keen in taking their decision in a good manner to provide a better insights in the construction practices. When we recap this section, we say that we understand the stress path is a key asset for the geotechnical engineers and designers. By comprehending the tracks of the total stress path, effective stress path professional can accurately interpret the test result and predict the soil behavior. These soil concepts provide essential tools for tackling the complex projects and ensuring the safety and stability of different infrastructure projects which are going across the globe. Okay, now see, now we talk about the stress path in the geotechnical engineering in aspects. So we will go with to see the book definition, and then we will move ahead. So see, first of all, what is written over there. So the first point mentioned over here about the stress path is a curve. Okay, sorry, give me a minute. Okay, so a stress path is a curve or a straight line which is the locus of a series of stress points depicting the changes in the stress in a test specimen or in a soil element in situ during loading or unloading. engineered in the triaxial test in a former case or caused by the forces of nature. Yes, that is explained. And an elementary way to monitor the stress changes is by showing the Mohr's stress circle at the different stages of loading and unloading. But this may be said as well as confusing when a number of circles are shown in the same diagram. As you are aware, when we are drawing the Mohr circle, right? I will show you. Okay. See, when we draw any graph, when we draw the Mohr circle, like we when we draw the Mohr Coulomb failure envelope, first of all, I will draw a line. Suppose this is the failure envelope, and when we draw a Mohr circle, so these lines are quite confusing in one way or the other. These lines are quite confusing as this value is sigma 3, and then value is sigma 1, then again sigma 3 dash and sigma 1 dash. In this way, we are drawing earlier sigma 3 double dash and sigma 1 double dash. So, what is the problem that this graph is too much confusing? If one is not aware what we have studied earlier, is not aware we are about, we say what are these things? I don't get it. What is this? We just understand that this is a Mohr Coulomb failure envelope. This where is my pen? Okay. This is the envelope line, and below which, if it is there, it will be safe, and above that, it will be fail. But when we draw the PQ curve, when we draw the PQ curve, that is sigma 1 plus sigma 3 by 2 versus sigma 1 minus sigma 3 by 2, that line is going to be straight line. So we are able to depict the interrelation in a good manner, and that's only thing I want to state. Okay. See, so we are talking about it is as an elementary way to monitor the stress changes is by showing the mover stress circle at the different stages of loading and unloading, but this may be cumbersome as well as the confusing when a number of circles are shown in the same diagram. Stress path approach enable the designers, engineers, professionals to predict and monitor the shear strength mobilized at any stage of loading and unloading in order to ensure the stability of the foundation soil. And when you see the approach which is suggested by the Lambe and Whiteman 1969 have suggested the locus of the points represented the maximum shear stress acting on a soil at the different stages be treated as the stress path which can be drawn and studied in the place of the corresponding Mohr circles. This is shown in the figure over here. You can see the stress path is shown. Mohr circle is considered sigma 1 and sigma 3, and on the basis of that, when we plot the sigma tau graph, it is represented over here in the 8.23 figure A, and when we see the figure 8.23B over the stress path is represented over there, and the point 1, point 2, point 3, point 4 is represented only. So, in this manner, the stress path we are able to form. Now we will see, as I have repeated several times, the coordinate of the point in the stress path Q as sigma 1 minus sigma 3 by 2, and P as sigma 1 plus sigma 3 by 2. Over here again, what is the value of sigma 1 and sigma 3? So the value of sigma 1 minus sigma 3 when we talk in the Q is nothing but the deviatic stress, and when we consider separately as sigma 3, so sigma 3 is nothing but the confining stress, and sigma 1 minus sigma 3 is a deviatic stress. By that manner we are able to find the value of sigma 1, and as we are forming earlier the Mohr Coulomb failure envelope with the help of sigma 1 sigma 3, now we are able to form the graph which representing the stress and stress, basically PQ curve, the deviating stress in which say the deviating stress on the y-axis and the average of the sigma 1 and sigma 3 value on the x-axis, which will be plotted over here to show the interpretation of the result which we are plotting. Now consider a case when the sigma 1 and sigma 3 are vertical and horizontal principal stresses. So this become Q as sigma V minus sigma H by 2 and P as sigma V plus sigma H by 2, and as the one either the effective stress or the total stress may be used for this purpose. The basic type of stress path and coordinates are represented as these only. As you see, one more point I want to add on over here, that when you consider the sigma b and sigma h, you say that the sigma b minus sigma h by 2 is nothing but the sigma 1 minus sigma 3 by 2. There is a question we have seen earlier in which the stress in the vertical and the horizontal direction are represented. So over there you will see that the vertical stress is written and the horizontal stress is written over there. By the calculation we are going to form the value of sigma n, and we have solved the find the value of shear stress. So that interrelation could also be established. So over here you can see in the effective stress path the coordinates are as for the p dash and q dash as sigma 1 bar plus sigma 3 bar by 2, and similarly for the q dash is sigma 1 bar minus sigma 3 bar by 2, and this is nothing but p dash and q dash. And when we say p, what is the value of p dash? So p dash is nothing but p dash plus p dash is nothing but p minus u, and q dash is nothing but q minus u, which is written over here in the total stress condition, like the total p is PT is P dash plus U and QP is QT is Q dash plus U. When we consider in the total stress condition, so there will be no reduction for the U. So sigma 1 plus sigma 3 by 2 is the coordinate for the P, and sigma 1 minus sigma 3 by 2 is the coordinate for Q. When we consider the stress path of the total stress less static pore water pressure condition, so we can write nothing but this is the same thing that we are talking about earlier TSSP, in which we subtract the pore water pressure under the static condition. So we subtracted the sigma 1 minus sigma 1 plus sigma 3 by 2 minus u naught, and similarly when we subtract this in the second case, that not the problem, because the sigma 1 minus sigma 3 minus u, the value of u gets subtracted from one another. So that not the case over there. So u naught is the static pore water pressure, which is shown over here. And now you see when we talk about the u naught zero in the conventional triaxial test, and the B and C coincide this case. But if the back pressure is used in the test as U not equal to back pressure for an in situ element, the static pore water pressure depend upon the level of the ground table. So the slope of the stress path is given as delta q by delta p, because when we plot this you see I have to activate the pen. When we plot this pq graph, p is over here, q is over here. Okay, so for this graph there must be a slope, there must be a slope. There must be an angle. So this slope could be able to find by delta q by delta f p, and delta q is q final minus q naught, and delta p is p final minus p naught. And in this manner we are able to calculate this. Over there the qf and pf are the coordinates at the failure, and q naught and p naught are at the initial coordinate. So tau f is written as c plus sigma tan phi, which is represented over here, can be shown from the equation written in the this slide. Now you see another case for the drained test. So the figure which is coming in the subsequent slides, we see that a typical stress path in which the point A corresponds to the stress condition with only confining pressure acting. So only confining pressure acting, so the value of sigma 1 and sigma 3 are equal because there will be no derivative stress. So as we know the sigma D equal to 0, so sigma 1 minus sigma 3 equal to 0. Okay, I will write that because you get confused maybe. So we know at any point if only confining pressure is acting. So confining pressure is nothing but sigma 3. Sigma 3 is equal to some value, suppose x. And the value of only confining pressure is acting. This means the value of sigma d is 0. Sigma d is equal to 0. This implies sigma 1 minus sigma 3 equal to 0. Sigma 1 minus sigma 3 equal to 0. So this implies sigma 1 is equal to sigma 3, right? Yes. And tau equal to 0. So the point F represents the failure and the stress path for the effective stress, total stress and the total stressless static pore water pressure as shown when we see this image. So in this image you can find very easily the thing like that for the consolidated undrained test on normally consolidated clay. The figure below shows the typical stress path in which the failure in the LUP is represented, and in this figure we can see that the ESP, TSSP and TSP are represented. So the point A you can see how the TSSP, ESP is represented and the failure envelope is formed and the stress path for the different condition gets formed in this way as we consider the static pore water pressure for the TSSP and in the ESP we subtract the pore water pressure in general and the TSSP the total stress is considered. So the stress path for the consolidation and trend triaxial test for normally consolidated clay is represented in this fashion. Okay. Now you can see another picture, another figure in which the consolidated undrained test on over consolidated clay is represented and the failure envelope is again shown and figure show the TSSP, TSP and TTSSP curve as below. So now we will see that as a note that the TSSP to the right of ESP, TSSP is the right of ESP, yes, you can see over here as well in this figure as well, TSSP is the right of ESP and uh, TSSP is TSSP is the right of ESP and um, for the positive axis pore water pressure and TSSP is the left of ESP for indicated for the negative axis pore water pressure. So both coincides for zero axis pore water pressure. So over here we understood those concepts. Okay, so with this I will take a small break over here and I will leave you with this question. In a break time, try to solve this, and when we come back, we will start our things by solving this question. So over here I am taking the 5 minute break. Right. So we will come after 5 minute break. So till then I will leave you with this question. Try to solve this question. If you are able to solve it, it's okay. If not, that's not a problem. I am going to solve in any case. So or you can also take a 5 minute break and we will start at 4 in a 5 minute time. No. Welcome back, everyone. Yes. Okay, so we have a stop over here. Oh, I think so. My screen is visible. Right. Okay, so we will start from here where we have left last time, and not last time, during before the break, 5 minutes earlier. So we will carry forward from here and sum up our session in next 1 hour. Okay, so we are talking about the stress part. Now this is a very good, very interesting problem related to stress part. So we will start with this. I will take a pen and then I will move ahead. Okay. So the pen is so the question is that the stress path equation for a triaxial test application of the diabetic stress is Q equal to 10 root 3 plus 0.5 P, the respective value of cohesion C, and then the angle of internal friction phi, this is nothing phi, yeah, R. So we know that over here the relation is given, and we know something like sigma 1. First of all, this relation is very much important. Mm, okay, see, I think so. My screen is visible. I will write over here. So we know the sigma 1 is equal to sigma 1 equal to sigma 3 10 square 45 plus 5 by 2 plus 2c 10 45 plus 5 by 2. And we have to find the value of cohesion and phi. And over here, the equation is given as, wait, take a minute, I will see. The equation is given as Q equal to 10 root 3 plus 0.5 P. 10 root 3 plus 0.5 P. Q equal to 10 root 3 plus 0.5 P. Oh, yeah, without that black skin doesn't get saved, no? Okay. Give me a minute. Okay, see over here. Okay, we have Q equal to 10 root 3 plus 0.5 P, right? And we know Q is nothing equal to sigma 1 minus sigma 3 by 2. Sigma 1 minus sigma 3 upon 2 equal to 10 root 3 plus 0.5. P is nothing but sigma 1 plus sigma 3 by 2. Right. So when you solve it and you are able to find that this is sigma 1 minus sigma 3 by 2 and this is sigma 1 plus sigma 3 by 2. So sigma 1 by 2, um, Q is sigma 1 minus sigma 3 by 2 and 10 root 3 P is sigma 1 plus sigma 3 by 2. I think so. I written something different in over here. Maybe this not be the question. So whatever is the question. So you what you do? You form this in the form of sigma 1 equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. After that, when you form this in this form, what you will know when you form in this form, you have known the value of tan square 45 plus 5 by 2 and 2c tan 45 plus 5 by 2. So ultimately you are able to get the answer as you compare 2c tan 45 plus 5 by 2 with that constant value and sigma 1, as I can see sigma 1 by 2 is this side as well as sigma 1 by 2 is that side. So I think so over here minus sign is there. I think the minus sigma 3 by 2. Okay, so in some wrong question I have written over here. That's why I'm not getting sigma q equal to 10 root 3 plus 0.5 p. So, okay, so you can see over here when we solve in this fashion, we are able to get the value of CH 20 and phi 30. Okay, if the time permits, in the last I will solve manually what I am doing showing on that screen. I will solve it manually for you, but if time doesn't permit, I explain from here only. So you can see over here, we have plotted the sigma 1 plus sigma 3 by 2, sigma 1 minus sigma 3 by 2 in that fashion and q equal to 10 root 3 plus 0.5 p. So over here c cos phi is 10 root 3 and tan beta equal to sin phi equal to 0.5. From here the value of phi is found and cn is also mentioned. But I will try to solve it manually during the end of this class if the time permits. Otherwise, I will try to solve in the subsequent class as well. That's not this. Okay, now I will move ahead with the topic called understanding the soil stress path and their application. because I have till from the first class only that anything we read must have some application significance. Otherwise, what is the need to study the any topics or the any subject, whatever we are going across? Okay. So the soil stress path play a pivotal role in the geotechnical engineering design and analysis. We will explore, we have explored the three type of system, that is the total stress path, effective stress path, and the total stress path minus the pore water pressure, that is the TSSP. When we call the pore water pressure and the material behavior, so the pore water pressure differences at the failure define the different soil behavior. Positive pore pressure you correspond to the normally consolidated soil, and the negative pore pressure try to the over consolidated soil. Application of the stress path reveal how the pore water pressure influences the behavior, as we see that due to the poor water pressure, when we see the difference in the total and effective stress, we can see that how its variation replicating in the field. Triaxial testing and a parameter variation, when we say, so stress path help in determination of a parameter. You have remembered the Skempton parameter A and B, where B is the delta U by delta sigma 3 and A is the delta U minus and A bar is the delta U by change in pore water pressure by changing the derivative state. On the basis of that, we are able to find the value of A as A bar into B is equal to value of A. So by plotting A parameter, the variation, we gain insight into the soil behavior under the different stress conditions. When we talk about the isotropic compression and the stress path in isotropic compression, stress path translate vertically due to the uniform stress changes, and the total stress path and the effective stress path in isotropic compression help analyze stress strain relationship. When we talk about his utilization soil stress path for the stability analysis, stress paths are the pivotal stability analysis. The Skempton equation define the pore water pressure U using A and B parameter, and the stress path help in identify the limit of loading before the soil failure. When we talk about the implication of design and construction, so we understand the stress path is essential for the safe design and construction. Tailoring construction plan to the soil behavior ensures the stability and avoid the failure. The relationship between the loading and the soil response is the critical for the success of project. This is the most important factor. This is the most important factor, right? Okay. Now we talk about the practical example, like the real tracks or the dolphin. In a real world example, showcase that the importance of the stress loading behavior, capacity of the rail tracks, stall building depend on soil behavior. The proper understanding ensures the efficient and secure infrastructure development. And as we recap this section, we say that the soil stress path provides a vital insight into the soil behavior and stability. Mastering the stress path analysis enhances the geotechnical engineer's design. Specifically, when we say mastering that, when we understand the soil path, stress path in actual, we are able to answer the many questions which we are not able to answer at the present time. Similarly, the continual learning and the application of the stress path concepts are crucial for the successful project. And by developing into the soil stress path and their implications, you or we gained valuable knowledge to enhance our work in the geotechnical engineering aspects. And one important thing to remember that the understanding stress path is like is like the language, understanding a language of the soil and helping us as a designer or the structural engineers that will help in the time of design. Okay, now we talk about the soil behavior through the stress path. Okay, so over here we see Mhm. Stress path is a guiding principle in the geotechnical engineering analysis. We talk about the total stress path, effective stress path, and the total stress minus the static pore water pressure. So, the pore pressure role is defining in soil characteristics. The pore pressure could be the positive or negative. So, okay, give me a minute. Screen. Right. So we are talking about the pore water pressure. We know that the pore pressure is one of the most important parameter because we have said earlier, and again I am telling that the water is the biggest enemy of the soil. If the water table is not there at any point of place, basically the water table is far below the ground, the designers, engineers are very much relaxed that the structure, the 80% of the geotechnical problem or the 90% of the geotechnical problem get eradicated. But if the water table is there, what type of soil and what are the behavior on, like when we consider the black cotton soil or the collapsible soil, over there the water table plays the most important role. At some places, the marshy land get created like the daldal when we say it in Hindi. So those things are specifically implemented with the water. If water is not there, it is said to be okay. We can do something over there. We can construct over there. But if the water is there, that is the biggest problem. So the pore pressure role in defining the characteristics of the soil is very much important. The pore pressure is the positive pore pressure that indicate the normally consolidated soil, and the negative pore pressure define the over consolidated soil because the stress at those sites in the prehistoric time is applied more, but it is actually applied at the present time is represented as the negative pore pressure. And when we say that the implications of the stress path on the soil behavior, it replicate in the isotropic compression stress path shaped uniformly. Total stress path and the effective stress path in the isotropic compression in elucidate the stress strain correlation. And when we talk about the soil stress path for the stability analysis, stress path indispensable in the stability assessment. Scampton equations define the pore water pressure using A and B parameter. The stress path determine the limit of the loading before the soil failure. Okay. And when we talk about some more implementation in the field of engineering, we say that the profound implementation of a stress path on the design and the construction plans to the soil behavior ensures stability, and the link between the loading and the soil response govern the project success. Basically, the success of the project is complementary depend on those factors only. And when we talk about in the real world scenario, as you talk about the rail track and the tall building, so in the real world applications, it underscores the stress path significance and the load bearing capacity of the rail tracks and the skyscraper hinges on the soil behavior and the stress path. Basically, when we construct those type of structure, we consider the value of the shear strength and the more column in build up along with the stress path which implement that how much height and how the pressure is going to takes place as the construction go on. And it also helps in understanding to ensure the secure and the effective infrastructure development for the sustainable growth. When we sum up this section, we say that the soil stress path a window into the soil behavior and stability. When a person get mastery of stress path analysis, enhance the geotechnical engineering design, and its learning and the practical application of the stress path concept help the project in excellence by delving into the intrinsics of the soil stress path. One can empowered themselves with the profound knowledge to enhance the geotechnical engineering endeavors. And one thing to remember that the stress path enable us to craft structures that stand resolute against the test of the time, rest of the time. When we move to the next section, we say that when we move to the next section, we talk about the plastic equilibrium of soil, and over here we are talking about the shear strength introduction of plastic equilibrium. So here we are going to signify one most important aspect that the how much value of stress is applied in a specific condition to sustain the specific amount of load. When we go in those aspects, we talk about the significance testing and interpretation of the shear strength and the transition of plastic equilibrium into the soil. As we understood, we have understand the strength of material. We talk about the elastic and plastic. So over here in the soil, how the plastic equilibrium get achieved, what are the factors, what are the implementations, and what are the concerns we need to take care of, which we are going to take those things from here onward. So first of all, talk about the applications which are associated with the plastic equilibrium. We say that unveiling the practical application of the plastic equilibrium, that it is in the retaining wall and the retention schemes. It is shown the practical implementation get rectified is resembled. And when we talk about the seed piles, like the bracing and cut of the soil over there, also the plastic equilibrium is represented. And introduction to the different type of seed piles and cut and non-anchored are also the some of the applicatory example. When we talk about the retaining wall and the earth pressure coefficient, we know that in the retaining wall and their design consideration, the earth pressure coefficient Kp and Ka are come into action. Over here, you can see the passive earth pressure Kp is said to be inverse of active earth pressure, as active earth pressure is inversely proportional to passive earth pressure. So K into Kp K into Kp are inversely K and Kp are inversely related, that is K is equal to 1 by Kp. And when we talk about the interrelation to find the coefficient of active earth pressure, we say 1 minus sine phi by 1 plus sine phi, where phi is the angle of internal friction. Conversely, when we talk about the passive earth pressure coefficient, we say 1 plus sine phi by 1 minus sine phi. And when we talk about the earth pressure coefficient in the rest condition, so that is written to be 1 minus sine phi or mu by 1 minus mu, depending upon the what are the known component known for us at the time of evaluation. So we are taking those things into our account, right? Okay. See, now we are talking about the earth pressure coefficient. As I have said that the active earth pressure and passive earth pressure. So what do we mean by that? That is also important. Okay, so the active earth pressure and passive earth pressure are the two of the aspects which we are talking about. So when we talk about the active earth pressure, the active earth pressure is that condition in which the wall is moving toward the soil. Soil is moving away from the soil, away from the wall. The specific embankment behind which the soil is there. In that condition, soil is moving away. Is that condition in which the active state gets formed. Over here, you can see in the first diagram, it is said that it is in the active state. Okay. See, if we consider a condition in which this is a wall and there is a soil over there. So for the active state, right? For the active state, the soil is moving away from the wall. This is the active state, and for the passive state, similarly, the soil is moving toward the wall, and this is nothing but a wall. This is wall, right? So when the soil is moving away from the this wall, this is said to be in the active condition, and when it is moving toward the wall, it is said to be passive condition, right? I think so. This much understanding you have at this point of time, and not to worry, we are discussing about this thing only in the next class. Over there we are going in detail of the active and passive earth pressure and how it get calculated, how the implementation are there. So over there we will see in this detail. So over here the soil is moving away from wall, soil is moving toward the wall, is the active earth pressure and the passive earth pressure condition, where the over here equation also represented at the Kp is 1 plus sin phi by 1 minus sin phi, and K is 1 minus sin phi by 1 plus sin phi. Okay. Okay. See, now we are talking about some more points like the stabilizing and destabilizing forces. Obviously, some force try to stabilize and some force try to overturn it, because when we talk about the gravity dam or other things, you must read in the water resources at also some point of time that the resisting force is there, where the resultant force get acted, so we are able to get the factor of safety or the amount of forces required to resist the applied moment, so that we will see. So over here you we need to understand the forces that stabilize and destabilize the soil system. Stabilizing the forces, the role of shear strength, and destabilizing forces are the gravity, rain, snow, earthquake, and the human intervention. Right? Human intervention is the one of the most important destabilizing forces, because as we see, sometime before we have seen the several landslides takes place at in Wayanad or many more places. So we in the Uttarakhand as well. Recently in Uttarakhand, so some experts have said that this is due to we have disturbed the ecosystem over here in one way or the other. As the more people are traveling over there for the pilgrim sites, so we are constructing the more structures by making the plain surface on near the river plain, so that also result in the damage of the infrastructure over there, because if people live there, they utilize the resources. In the some mountainous region, when mountain get cut out to make the plain for the construction of the some projects, so that also lead to one of the most important problematic decision. So we, as a people, need to understand that we need to try to harm as less as to the natural habitat or the natural environment, so that we will also become safe. Because if we are trying to more utilize the things which is which need not to be, that will create a greater disaster in future in one way or the other, right? Okay. Okay, so we are talking about the stabilizing forces and the destabilizing forces, and destabilizing force when we talk about the human intervention. So by the human intervention is the same thing, only that if we try to change the path of the river, if we try to make the dams is not the problem, but if we try to make cut out the mountain to make the plain for the construction activity or the production of the crops activity at some places, that also leads to the these type of disasters. So this need to be understood. Okay, when we talk about the ground stabilization and the shear strength enhancement, this focus on the scenario with a very low shear strength, like in the marine deposit, and highlighting the art of the geomechanics, enhancing stabilizing force against odds, and the ground stabilization, soil improvement, and the path to soil reinforcement. When we talk about insight from the Poisson ratio and the K parameter, so introducing the Poisson ratio and its relation to the K parameter, so Poisson ratio rho in relation to stress ratio sigma h by sigma b, and K naught as a function of RDOCR soil type and the water content, obviously, because it depends on the over consolidation ratio. Some important aspects get multiplied for the over concentration ratio as well, and the soil type is very much important because it's on the basis of soil type we find the value of phi from which we are considering the coefficients of earth pressure. And when we conclude this section of the plastic equilibrium, we say that it act as a bridge which bound the gap between the elastic and plastic state, and the grasping the significance of plastic equilibrium in soil mechanics help us in one way or the other, and it is occupied to tackle the practical mechanical challenges through the deep understanding of the plastic equilibrium. When we are going to conclude this section, not a session, one thing need to be remembered by one and all, that the stability and instability is one part of soil system in which uh, the armed with the knowledge of plastic equilibrium, we are ready to venture in the real world geotechnical engineering, where the principles we will discuss will guide us in shaping a stable, secure environment in one way or the other. Now we talk about the plastic equilibrium in soil. We say that the parameter sections real life application is one of the most important things, and the concepts, some concepts like the definition when we talk about the state of stress at which the soil is on the verge of failure is said to be that conditions. When we talk about the importance, we say that understanding the cause of the stress development and the application in the engineering. Retaining was slope analysis, bearing capacity assessment are some of the main applications when we talk about the plastic equilibrium consideration, and its application in the retention schemes like the designing of retaining wall and the seed pile wall bracing, analysis of crust excavation and the different seed pile styles are some of the most important implementation when we talk about the plastic equilibrium case. And as we go ahead, we see that the in the slope stability is objective to preventing instability and failure, because we said earlier that its plastic equilibrium act as a bridge between the elastic and plastic, and analysis of the finite and infinite slopes help over there with the help of plastic equilibrium or the limit equilibrium case specifically for the slope, and emphasis on the slope stability analysis method. When we talk about the bearing capacity of soil, its relevance gets increased because of the foundation design, the broad application to both the soil and rocks, linking the failure causes to a stabilizing and destabilizing of forces get over there, and those calculation is also over there when we talk about the force acting in the downward direction in the oriental direction, and the location of the force we are going to found. Specifically, when we study the active and passive earth pressure over there, we come to know about those things in very clarity. When we talk about the clarification of the plastic equilibrium, it's in the concept of plasticity and the plastic deformation. And as you know that the elastic and plastic deformation doesn't get retrieved. So this is the deformation which are there and remain forever in one way or the other. And when we talk about the passive and active earth pressure, so the passive earth pressure is the condition leading to the passive state. And when we talk about the passive state, we see that in that condition the soil is moving toward the wall, so the stress in the horizontal direction get increased, and over there the stress in the horizontal direction is more than the vertical direction, and the relation to the shear strength is also stated in the same manner. State of stress where the plane converges is also found for the passive state of stress, and the inclination of the failure plane is 45 minus 5 by 2. Similarly, for the active earth pressure, the condition of loading to the active state pressure state of stress where the plane diverges, and the inclination over here is the 45 plus 5 by 2, which is the different from the passive, that is the 45 minus 5 by 2. And when we go ahead, when we conclude or recap this section, we say that the plastic equilibrium as a fundamental concept in the geotechnical engineering, application in designing table structures and preventing failure, acknowledging the role of the gravity and the geology in shaping the soil behavior and the state of stresses. Okay, now we will start with some of the small questions before we sum up the today's session. So we will take a very small problems and then we will end up the today's session. And as I have said earlier, that we are going to solve that effective stress paths problem as well in the end. Okay, see, the first question is the active pressure for the design of bridge abutment is taken as the active thrust, passive thrust, thrust in the rest condition, or none of the above. The question itself states, okay, I will take a pen. Okay, the question says the earth pressure for the design of bridge abutment is taken as active thrust, passive thrust, the thrust in the rest condition, or none of above. So over here, the none of above is sorry. Over here, the thrust in the rest condition is the correct option because, as we know, that the bridge abutment is, as we know, the bridge abutment is taken as the thrust in rest condition because when we talk about the bridge, there is the no soil pressure acting in specifically toward the bridge abutment or away from the bridge abutment. So it acts as in the rest condition. When we see the explanation, we say at rest the earth produce the pressure exists when the wall earth system is rigid, that is when no movement is occurring as a case of the deep basement wall or the U-shaped abutment bridges. The next question is a vertical next question is vertical wall 6 meter high above the water table retains a 20-degree slope. The retaining soil has a unit weight of 18 kilonewton per meter cube. Approximate shear strength parameters C parameters are 0 and 40 degree. The coefficient of active earth pressure to be used for estimating the active pressure acting on the wall. Okay. Okay, so what is given over here? First of all, see, the given is 6 meter high, a vertical wall 6 meter high above the water table, retain a 20-degree slope. So beta is given as 20 degree, right? Right. And the retained soil has a unit weight of 18 kilonewton per meter cube, means gamma is 18 kilonewton per meter. Okay. And the approximate shear strength parameter C and 5 है basically 40 degree the coefficient of active earth pressure using earth pressure coefficient. So over here we know K equal to cos beta into minus cos square beta minus cos square alpha by cos beta plus root under cos square beta minus cos square alpha. So by as we know the value of beta as 20 degree, alpha as 40 degree, so we are able to find the value of K as 0.25. Okay, there will be no problem up to here, I think so. Yes. So the next question is for the determination of the earth pressure. Coulomb Gauge theory assumes that the back of the wall is smooth and vertical. Okay. Okay, we have not read this very firmly, but as of now, we will take this question and we will carry forward this concept in the next class as well. But okay, this is a small problem. I think so everyone know. For the determination of earth pressure, Coulomb wave theory assume that a back of wall is smooth and vertical, slightly non-homogeneous and isotropic slip surface is circular or rough. So the answer for this is the D. Oh, sorry. And the answer for this is D, that is wall surface is rough. For the determination of earth pressure, Coulomb theory assumed that the wall surface is rough, not smooth and vertical, because we are talking about the Coulomb wedge theory. And Swahili non-homogeneous and isotropic is also wrong answer, because Swahili is always going to be a homogeneous and isotropic. Cliff surface is not circular, so the wall surface is rough is the correct answer. Okay, we come to the end, but as I said earlier that I am going to solve that problem which we have left behind. Okay, let me find that problem first of all. Yes. Uh, Q equal to 10 root 3 plus 0.5 p. We are talking about this problem. 10 root 3 plus 0.5 p. I will take a screen over here only and I will solve over here so that it will be remain with you. Give me a minute. Give me a minute, please. Okay, so this is the question and I am going to solve it over here. Okay. So first of all, the question state that Q equal to 10 root 3 plus 0.5 p. So I will solve over here. It's say Q equal to 10 root 3 plus 0.5 p. 0.5 p. Okay, so this is the last question for today, and with this we will end the today's session by solving this because I have explained this, but over there the solution some confusing things are there, so I try to solve by my own. Sigma 1 minus sigma 3 by 2 q is you know already, right? And equal to 10 root 3 is 10 root 3 only, and 0.5 p is sigma 1 plus p sigma 1 plus sigma 3 by 2, so sigma 1 plus sigma 3 upon 4 it will be going to be because already 2 by 2, and when we solve it it will be sigma 1 by 2 minus sigma 1 by 4, so 1 by 2 0.5 minus 0.25 0.25, so sigma 1 by 4, right? I am doing calculation in my mind, so maybe some mistake at some point of time, but 0.5 minus 0.25 is 0.25, so sigma 1 by 4 equal to sigma 3 by 2 and sigma over here also sigma 3. So 1 by 2 plus 1 by 4, 0.5 plus 0.25. So 0.75 means 3 by 4. 3 by 4 sigma 3, right? Plus 10 root 3. Okay. And when we solve it, it will be sigma 1 equal to 3 sigma 3 plus 40 sigma plus 40 root 3, right? And when we write over here our equation, that is sigma 1 equal to sigma 1 equal to sigma 3 10 square 45 plus 5 by 2 and 10 square 45 plus 5 by 2 plus 2c 10 45 plus 5 by 2 plus 2c 10 45 plus 5 by 2c 10 45 plus 5 by 2, right? Okay, so over here we come to know 10 square 45 plus 5 by 2 is equal to 3 from this. So we will write 10 square 10 square 45 plus 5 by 2 45 plus 5 by 2 45 plus 5 by 2 is equal to 3. When we solve it, we get to know phi is equal to, okay, I will use the calculator for a while and then I will tell you answer. Give me a minute. Root 3, tan inverse root 3. Tan inverse root 3 minus 45 multiplied by 2. So phi, we are going to get phi equal to 30 degree. And when we find the next, that is 2c tan 45 plus 5 by 2 equal to 40 root 3, right? 2c from here, this is nothing but this. 2c tan 45 plus 5 by 2 equal to 40 root 3. So I will write 2c tan 45 plus 5 by 2, 2c tan 45 plus 5 by 2. I think so I am clear from up to here. There will be no doubt in anyone's mind because I have stated many times this and the solution which is mentioned over there is in the different form. So there might be some confusion in some of you. That's why I try to solve it by myself. 40 root 3 and as phi is equal to 30. So this is going to be 2c 10 45 plus 5 by 2 pi 30 30 by 2 is 15 so 2c 10 60 2c 10 60 is equal to 40 root 3 and when we will solve over here I will use the calculator again for the circle and when we solve 40 root 3 um, equal to divided by 10 60, right? 40 root 3 divided by 10 60 upon 2. So we are going to find the value of C cohesion as 20. So I think so that is the answer which is mentioned over here in the solution as well. I can show you that see that phi equal to 30 and c equal to 20 is the answer and which we got here. So the simple thing is that we use our the basic equation that is sigma 1 equal to sigma 3 times square 45 plus 5 by 2 plus 2c times 45 plus 5 by 2. We have rearranged the things which is mentioned over here in that fashion only and you are able to get the desired answer which you are looking for. So I am keen to solve this problem as I have said earlier. So with this, I will sum up the today's session. In the today's session, we have understood the effective stress path and some of the problem related to the same. So I will suggest you to solve some problem on the basis of these things, and that will help you in the better understanding. These are some of the reference books which you can go across, or some other books are also mentioned in the post descriptions at the NPTEL sites. You can go across those book as well and find problem, solve it out. If you have any doubt in the any of the problem, you can write in the chat box or in the forum. I will try to answer them all and try to solve all the assignment on time so that you get your evaluation in right order. So with this, I will sum up the today's session. Thank you everyone for attending the session. We will meet again in the next session. And so I think so and the understanding which you get from this course up to here will be very much clear. In the next class, we are going to study the active earth pressure, passive earth pressure concepts, and the problem related to the same. So, with this, I will end the today's session. We will meet you in the next class. Thank you everyone for attending the session. Wish you a very happy weekend. Thank you very much.